Welcome back. In this session we're going to see how to write context-free grammars with NooJ. So as a reminder, context-free grammars are equivalent to type 2 generative grammars in Chomsky-Schutzenberger's hierarchy. Context-free grammars can be more powerful than regular grammars. They can recognize any context-free language, are very well adapted to describe structured and embedded linguistic units, such as embedded sentences, and they can be processed by push-down automata. So how do we go from regular expressions to context-free grammars? So remember that when you open a text or a corpus, you can type in a regular expression by using the menu item text locate, and then you can type in something like International Business Machine, pipe, IBM, pipe, Big Blue, pipe, the Armonk firm. But let's say you have many regular expressions such as this one. You want to keep them, you want to save them. And then you need to name them in order to find them. So what you can do now with NooJ is to name regular expressions. For example, I could write something like IBM equals International Business Machine, IBM, Big Blue, the Armonk firm. And then, when you have a named query, you can reuse it. So for example, let's say I have a named query such as buy equals buy, buys, buying, bought, buyer, buyers. What I can do is reuse this query, this regular expression, in another query, in another regular expression. So here I can now define another query, another regular expression. Well, I'm going to name it trade, in which I will use by, which is itself defined by a regular expression. And we can continue to play this game. For example, I can have another query, what I'm going to call it up, in which I will use trade, which is itself defined here, which itself uses the query by, and I can do that as many times as I want. So for example, if you remember the lexical field that I presented previously as a regular expression, actually in NooJ it's represented like that. So I have several rules, several queries, verbs, where I put some verbs, nouns, adjectives, and then expressions. And I reuse all these rules, all these queries, inside another rule, which is the main rule. And if I use this grammar, which is by the way saved in the file death.nog, if I apply it with NooJ to a text, for example here, death, I will get the concordance and of course statistical analysis, standard score, factorial analysis, evolution, frequencies, etc. I will have access to all the statistical tools. Now we are no longer limited to regular grammars, regular expressions. We can build complex grammars that consists of several rules, maybe dozens of rules, and rules can call other rules. And this is exactly what context-free grammars are. There are very good reasons to use context-free grammars to describe regular languages. So for example, if I want to describe all the sentences that have two complements, as an example, the very mean neighbor gave the red pen to my extremely rich cousin, I could write a regular grammar, determiner, followed by a noun, and between the determiner and the noun I have a sequence of adjectives, any number of adjectives, and each adjective could be preceded by an adverb. But then this is a subject, and then followed by a verb, and then the object complement will have exactly the same form as the subject, to, and then another complement which has exactly the same form. So you see there are some redundancies. It's really bad to have redundancy in a grammar, because let's say I want to change the form. Let's say I want to add the fact that I could have, instead of one adverb or no adverb, I could have as many as adverbs as possible. So if I want to modify this part, I must not forget to update this part and also this part. If there is a mistake, I have to correct to update all the three descriptions that are actually meant to be identical. So a better way to do it is to use a context-free grammar in which I define noun phrases, such as this way, a determiner followed by any number of adjectives followed by a noun, and then I use another rule, a main rule, that says my sentences, the sentences I want to describe, will consist of a noun phrase followed by a verb, followed by a noun phrase, followed by two, followed by a noun phrase, and notice that it's just exactly the same description that I'm using 3 times. So these are syntactic grammars. I can use also context-free grammars to describe some morphological or orthographical phenomena. For example, here, this is a context-free grammar that recognizes Roman numerals. So the idea is that I'm going to use a rule named units that recognize 1, 2, 3, 4, 5, 6, 7, 8, 9. Another rule to describe the tenth, 10, 20, 30, etc. And then my Roman numerals will be defined as tens, either followed by units or by nothing, or units. So this grammar will recognize, for example, 32. 30 here, XXX will be recognized by the rule 10, followed by 2 here, which will be recognized by units. So as an exercise, you can complete the grammar so that it will recognize all the Roman numerals up to 3,999. So please pause the video. And here is a solution. So I have defined already units, tens. Now I'm defining hundreds and thousands up to 3,000. And then I say that the Roman numerals consist of thousands or nothing, followed by hundreds or nothing, tens optional, or units optional. So this looks good, but this is a first attempt, and there is a major problem with this grammar, which is that by combining all these epsilon, the grammar is going to recognize the empty string. And that's very bad, because NooJ, if NooJ recognizes the empty string, it will recognize an infinite number of sequences at the very beginning of the text, before even reaching the first position, the first word in the text. So this is bad. NooJ refuses to process grammars that recognize the empty string. So we have to do something else, and this is a better solution. I would define Roman numerals as either just a thousands, so for example M, MM, or MMM, or thousands optional followed by hundreds, or optional thousands followed by optional hundreds followed by tens, or optional thousands, optional hundreds, optional tens followed by units. And this way, this grammar is guaranteed to recognize something, so it will not recognize the empty string. So this grammar is pretty good because it recognizes all the Roman numerals in a text, but maybe we want to go a little further. Maybe we want to convert these Roman numerals into Arabic notation, and this can be done by using enhanced grammars, which are grammars with an output. So here it is. So here, if I recognize I will produce Arabic number 1. If I recognize V, I will produce 5, etc. And then this grammar not only recognizes any Roman numerals up to 3,999, but also is going to produce the corresponding the corresponding number in Arabic notation. So as I said at the very beginning, context-free grammars are more powerful than regular grammars. And one important feature of context-free grammars is that they are recursive. So what is a recursion? A recursion is when a rule uses itself to define itself. So for example here, I have a rule, let's say sentence. I say that a sentence consists of a subject followed by a verb, followed by that, followed by sentence. So as you see here, sentence, the rule sentence is defined by itself. So this is called a recursion. It's defined recursively from itself. And these grammars are very powerful. For example, this grammar here can recognize the sentence, Jane said that Mary hoped that Eva thought that Joe slept. You see, Jane is recognized as a subject, subject Jane, said as a verb, here, verb said, and then that, and then a sentence. That, and then this, here recognizes this. And if I want to make sure that this sentence is recognized by this rule, I do it again. Here, sentence, subject, so that's Mary, followed by a verb, hoped, and then that sentence. And then this is going to be recognized by sentence. And how do I know that it works? Because I look again, sentence, so where am I? Here, Eva, subject, thought, verb, that, followed by a sentence, Joe slept. And I can do it again. Is this a sentence? So sentence, subject, Joe, followed by a verb, slept, followed by nothing. So this grammar, this very simple grammar with 3 rules, can recognize any number of embedded sentences to the right of the verb. This is very powerful. And actually there are 3 types of recursions: left recursions, right recursions, and general recursion. So a left recursion is when the reference that is used to define a rule, for example here, NP is defined by using NP, and you see that NP is at the left of the rule. So NP here is a prefix of the rule NP. So for example, this could be used to recognize things such as the house from Paris, in Paris, around Paris. The right recursion is when the reference, here for example, the reference to sentence is to the right, so it's a suffix of the rule that it defines. So sentence here is defined by NP, and NP is defined by sentence, and sentence is at the right of the rule, so it's a suffix of sentence. And the general recursion is when the recursion occurs neither to the left or to the right. For example here, sentence here occurs here, it's neither a prefix of sentence nor a suffix of sentence. And it's important to understand the 3 types of recursions because it is possible to remove left recursions automatically. So that's exactly what NooJ does. So when NooJ finds a rule such as this one, NP is defined by NP itself, NP being a prefix of NP. Well, NooJ can automatically replace this left recursive rule with a regular grammar. This grammar here, this grammar rule, is equivalent to this one, the house, and then from, in, around Paris with a star. And it's the same case for right recursions. When NooJ recognizes that a grammar is right recursive, so here sentence occurs as a suffix of sentence here, NooJ can replace this grammar, it can rewrite this grammar as a regular grammar, and this is the resulting regular grammar, and they are equivalent, they recognize exactly the same sentences. However, it's not possible to remove general recursions in a context-free grammars. It's a theoretical result. So if you enter a grammar such as sentence, dead, noun, that, sentence, verb, type verb, in which sentence is defined from sentence, but this sentence reference is neither a prefix nor a suffix of sentence, of the rule sentence, then this is a general recursion. It's not possible to remove it, to rewrite the grammar as a regular grammar. However, there is some interesting linguistic fact, which is this type of grammar corresponds to embedded clauses that are in the middle of sentences. For example, here, this grammar recognizes the sentence, the cat is sleeping. The cat here is sleeping. Okay? It will also recognize the sentence, the cat that my cousin bought is sleeping. The cat that my cousin bought is sleeping. And my cousin bought here is recognized as a sentence as my cousin bought. Okay? But let's go a little further and embed another sentence inside this sentence. So we get the cat that the neighbor my cousin knows bought is sleeping. And I must admit this sentence starts to be a little difficult to understand. And if we go even further, the cat that the neighbor, the cousin, her friend saw bought is sleeping, I would consider this as an incorrect sentence, impossible sentence, which means something. It means that maybe general recursion is not really linguistically valid. If there is some kind of maximum depth, now it's not context-free. It doesn't have the full power of the context-free grammar if we need to limit the number of embedding in a sentence. As a conclusion, linguists should not hesitate to use recursions to simplify their grammar. So context-free grammars are much easier to maintain and to design than regular grammars. NooJ can remove left and right recursions automatically. If the resulting grammar does not contain any more recursion, it is equivalent to a regular grammar, and NooJ knows how to apply regular grammars to text very, very efficiently. NooJ cannot remove all recursions. However, in that case, when there are some general recursions in a grammar, NooJ can impose a limitation on the depth of the recursions, for example, a maximum of 5 embedded relative clauses in a sentence, and the resulting grammar, which is not equivalent to the context-free grammar with any number of embedded clauses, but this resulting grammar can then be transformed into a regular grammar, and thus can be applied to text efficiently. So, congratulations again. You now know how to construct context-free grammars with NooJ and apply them to text in order to implement various NLP applications.